Okay, so in this very short video, I want to address what would happen if you swapped your u and your dv. I'm just going to play devil's advocate here. Let's go ahead and sort of take all this. Oops. Cut. Let me do a better job. I'm going to erase all this really good work. That's your answer, which you got from the last video. I don't want to copy it. Oh, geez. I want to cut it. There we go. Okay, let's say you came at this and you reverse them. How do you know that this would be wrong, right? Because you're humans, you're going to do it, I do it, it's totally fine. But I want to talk out, how do you know you're moving in the right direction or the wrong direction? So let's say I come at this and maybe you're like looking at it and you say, hey, this is a pretty good thing. I can set that to be u. I know what the cosine, the derivative of cosine is. The derivative of cosine is negative sine. That's not hard. That's pretty manageable. I can do that. Totally great. Then you'd say, well, the leftover pieces, right, this would have to be your dv. Totally acceptable. Totally great idea. And then you would come at this and say, well, let me integrate it so that I can say what v is. That's totally manageable, right? That's 3 halves x squared. Now, again, normally you'd have a plus c. I'm going to leave that off. But you can say, hey, that wasn't too bad. Nothing was horrible there. Let's see what happens when we use integration by parts. Now remember, integration by parts is u times v minus the integral of v du. Let's put it all together here. U times v would be cosine times this polynomial. And I think I'll write it like that. 3 halves x squared times cosine x minus the integral of v du. Okay, negative sine dx. Let me handle that for a second. I always like to get rid of all my negative problems up front. I have a minus on the integral and a negative on the inside. I'm going to change that to a positive. And I want you to look in here for a second. This right here is not a basic integral. That is a polynomial times a trig function, which is what we had when we started, right? But not only is it not great, it's actually worse. This is a worse integral than what we started with. This is more intricate than I had started. This is how you know, oh, I think I'm headed in the wrong direction. So when you get something that's not possible or just not any better, you're actually getting further away from a good response. That's when you would know, oh, okay, well, let me just think about it differently. It doesn't mean integration by parts is off the table. It means maybe reimagine what you set for u and dv. Similarly with u substitution, right? Sometimes you would set the wrong thing to be u. It didn't work out. It didn't mean u substitution failed. It meant go back in there and see if you make a different choice if it creates a better result. Okay, so I just wanted to show this to you so that you realize, how am I going to know if I'm headed in the wrong direction?